In lesson 15, we learn how to locate spatial points of intersection and to run line of best fit. The two put together make an interesting section. Please notice what follows. Again, it is locating spatial points of intersection and line of best fit. Now let us turn our attention to locating the spatial points of intersection. We borrow a process from what happened when I was doing simple Cartesian sketches. If you want to locate the spatial points of intersection, go back to your table. We have just located the tabular values on the axis. And now we want to see where the pairs of values of x and y meet in space. Finding out where they meet is what we mean by locating the spatial points of intersection. For instance, this table is what we have just plotted, or this table is what we are plotting right now. We have just finished locating the places where these values in the table are on the axis. Next will be in this space, in this graph page, where will -3 meet -19? Where will -2 meet -13? Where will -1 meet -7? And in that manner, until where will 2 meet 11? Let us see. Remember, I said, if you want to locate spatial points of intersection, you should go back to the table. This is our table, and I've gone back to it. Now, this is -3. What is it? See it here. This is -19. Where is it? It is below here. We're going to see it soon. Just like before, this -3 has to go down and meet -19. Let us see where they have met. But first, look at a line going down along this -x. It will meet -19 somewhere. Let's see where it meets it. See it more clearly. It meets -19 at this point. This dot here. See it. -3. Here. -19. The same place. So they meet at this point. This place is called the spatial point of intersection between -3 and -19. Let us see other points like this one. In like manner, we see where this -2 meets -13. -3 is here. It has to go down to meet -13. The x is -2. The y is -13. On this axis, we get -13 down, not up like this. That is why -3 must move down to meet -13. Let's see where it meets it. See it. This is where -2 has met -13. -2 down here and -13 leftwards to meet it at this point. This is therefore the spatial point of intersection between -2 and -13. Let us do the remaining ones. These are the other points of intersection after the first two. Recall we have done -3 against -19, -2 against -13. Now we do -1 against -7. See it here. -1 here against -7. Next is 0 against -1. This is 0. The origin is 0 against -1. See -1 here. Next is 1 for x and 5 for y. 1 for x keep going up above it until it meets 5 on y. This is 5 on the y. They meet here. The last one is 2 against 11. 2 on x. See it here. Against 11 on the y. These are the remaining points of intersection. Wonderful. You agree? Let us see how to do the next thing, which is to run a line of best fit. If we say line of best fit, what we're going to see and what we have seen before may not be the best examples of line of best fit, since this and others we have done before witnessed one thing. What is it? All the points entered into that line. It is when that line cannot enter all that we can speak about the line of best fit. But what else we call it? It is still called line of best fit. So this case here, we have just plotted, is not going to be the best example for line of best fit. In any case, we must run it. With the aid of a straight-edged meter rule, we have been able to produce line of best fit. See it here. That seems wonderful too. A wonderful line of best fit. But don't forget I said earlier, with this example, we cannot magnify the importance of that expression, best fit, because everything here fits. What you see on the screen is a near field view of the plotted work, x against y, for the table that we've been treating all this while.